everybody, so I hate to be on screen, but for this video I have to be. We're going to be talking about end behavior. And so end behavior is what's happening to the graph, which we're going to of course call f of x, as x gets really big. So when we talk about x getting really big, that means it's going further and further to the right. Now, remember, I'm the opposite of you, but as x goes this way, what happens to the graph? And also, as x goes really, really small, what happens to the graph this direction? So it's very, very simple. We only have to consider two things, the degree and the leading coefficient of any polynomial. So degree means what? Not that it got a bachelor's or anything like that. What does it mean? Degree means the highest exponent. So for example, the degree of these two functions is the same. They are both cubics because we've got x, x, x. That's a cubic, this is a cubic. The only difference is the leading coefficient. So this one has a leading coefficient of 1, and this one has a leading coefficient of -1. And their end behaviors are opposites. But since these are both cubic, they do something else. Now we already know that parabolas, which are x squared, both ends do the same thing. Either they both go straight up or they both go straight down, because we know it either opens straight up or it opens down. And so cubics are different, and things with odd degrees are different. So with odd degrees, your right side of your graph, so as x gets really, really big, the right side goes up, because that's positive, assuming that nothing strange has happened. And the left side will do exactly the opposite and go down. So if you have a degree of that is odd, your ends are doing this, assuming you have a leading coefficient that's positive. So that would be the top one. On the one on the other side, it does exactly the opposite. Just was what the negative does. So if the degree is odd, your ends are going to be doing opposite things, just depending on the leading coefficient. So just to illustrate this, let's go ahead and take a look at these two graphs in Desmos. So I've already got the first one up here. So this is the positive version. And you can see how the right side of the graph is going up. So as x is getting really, really big, this is going up. See, and it's already up here at 200. So by the time it's at 7, it's past 200. So as x gets really big, this shoots off really high. And as x gets really small, this shoots off really low. And so the way we write that, I'll show you in a minute, but then this one, if we switch it so it's negative, you can see that the graph is switched. So the left side now is going up, and the right side is going down. And so you can see that that's a very quick switch, just because of the negative sign in front, not there, right side goes up, there, right side goes down. So, going back to our graph, this is what we write. So we would say as x gets really, really big, and let me write, so for this one, as x gets really big, the function, so as x gets really big, that means approaching infinity, and my finger's not great at writing, so to give it a break, the function gets really big also. For this one, as x gets really big, the function gets really small. So we're just writing that. So x goes to infinity, gets really big. As I move to the right, it gets big. As I move to the right, it gets big. So I'm moving to the right, the function is shooting up or the function is shooting down. And that's the most important side, because the right side always goes up if the leading coefficient is positive, even or odd. Always goes up. So if it's even, if it's odd, even, odd. And so that's the key. So the key here is the degrees and the leading coefficients. So backing this up, let's take a look at two different functions now. Sorry about the bending. That's, gotta get to what you gotta get to. So these two functions, we've got x squared. They're exactly the same, except for instead of x in front, I've got x squared, meaning that this is now to the 4th power, and this is also to the 4th power, which means our degree is even. So if our degree is odd, opposite ends doing different things. If our degree is even, opposite ends doing the same thing. Okay? So let's take a look at these graphs in Desmos. So starting with x squared. So both ends are going up, which was what would happen with a quadratic. The difference is what's happening here in the middle where everything's crazy. So we've got our roots here at 5, -5, and +4. And at 0, we've got that double root happening because it's squared. And it's turning around. We talked about that the other day. But both ends are going up because it's even. And the ends have to do the same thing. For even, they're tied together. For odd, they're not. So if we make it negative, what will happen is the whole graph flips over. So the graphs are, now both ends are going down. So that's pretty much it. And so what you need to be able to do is when looking at a graph, you need to consider what's happening to the ends. As x gets really, really big, what is the function doing? And most of the time as x gets really big, the function is going to go to infinity with a polynomial. But if a, the leading coefficient, is negative, then x goes to positive. So again, right side always goes up, because right, up, up, up. The difference being then what? Leading coefficient, which makes this side switch. So what you need to do is what your other hand is doing. So, again, even, tied together. So x is positive, leading coefficient is positive, leading coefficient is negative, degree is even. Degree is even, degree is even. Degree is odd. The right side goes up, the left side goes down, opposite. So remember, I'm backwards, so you got to kind of think about that. But when you're looking at your paper, it will be backwards, so it's no big deal. And that's what we've got. So good luck with end behavior. Take a look at this wrong direction. Take a look at this problem, these problems on your paper. This is the video that this refers to. Take a look at these problems on the paper and make sure you figure out what's going on with the end behaviors here at the bottom. So again, x is getting really big. What's the function doing? So good luck and have a nice day.